Hey everyone, so in this video we're going to talk about perfect squares and what is a perfect square, trinomial, and what is a perfect square just as a number in itself. And so a reminder, a perfect square is the result of something times itself. So let's start basic with numbers. So 4 times 4 is 16, so 16 is a perfect square. I'm going to write down all of our perfect squares up into maybe where we get 100 as a result. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 and 4 is 16, 5 and 5 is 25, 6 and 6 is 36, 7 and 7 is 49, 8 and 8 is 64, 9 and 9 is 81, and 10 and 10 is 100. Okay, and you can go further than that, but these are the ones we're just going to look at for now. So these are all perfect squares. They are the result of multiplying something times itself. Now we have to look at, well, what happens when we have variables? So if I multiply x times x, that is multiplying something by itself, I get x squared. Okay, if I do x squared times x squared, I get x to the fourth. So x to the fourth is a perfect square. If I do x to the third times itself, which is x to the third, I get x to the sixth. And so if you don't remember how to multiply here, x to the third is really x times x times x. And x to the third again, you would have x times x times x. And so in total, this gives you x to the sixth. So what you can do is you keep the variable and you're going to add the exponents. Okay, x to the fourth is going to be times x to the fourth is going to be x to the eighth. Okay, so 2, 4, 6, here's x to the eighth. X to the fifth times x to the fifth is x to the 10th. X to the sixth times x to the sixth power is x to the 12th. And so you notice if your exponents are even, then it is a perfect square. And so these are how we get some of our perfect squares. Here are some perfect squares of some natural numbers or some counting numbers. And here are perfect squares of variables. Okay, now we're going to look at the difference of perfect squares. And so the difference of perfect squares, well, difference is subtraction. And so here's an example of the difference of perfect squares. X squared minus 25. Okay, these are both perfect squares. X squared is the result of x times x. And 25 is the result of 5 times 5. Okay, so this is the difference of perfect squares. You have subtraction and you have two perfect squares. And so when you go to factor, x is in the front. And so the two factors are multiplied together to get x squared go in the front. So I have x and x. So I have an x and an x. And I have 5 and 5. And so 5 and 5. And when you have the difference of perfect squares, one gets a plus and one gets a minus. And that's how you factor the difference of perfect squares. I'm going to do another example. Let's say 4y to the fourth minus, let's say 36x squared. Okay, so these are perfect squares. Well, what do I multiply by itself to get this? Well, 2 times 2 is going to give me the 4. So I know in the front I'm going to have a 2 and a 2. Y to the fourth, well, y squared times y squared gives me y to the fourth. Okay, I have the subtraction is here, so one can get a plus and one gets a minus. Well, what gives me 36? 6 and 6. And what gives me x squared? X and x. And so when you're looking to determine if you're going to factor using difference of perfect squares, you're looking to see, is one sign positive and one sign negative? And are the terms themselves perfect squares? Sometimes you'll see it in a tricky manner where they're switched. So for instance, negative 25x squared. And then you might see maybe a plus 36, right? And it's still difference of perfect squares. One is still positive and one is negative. This is a perfect square and so is this. And so the process would still be the same, right? The subtraction sign, whatever is attached to it, that's the part that gets the plus or minus. And so I have a positive 5 and a negative 5. So remember here, the subtraction was attached to the 36. So the 6s is what got the plus or minus. In this case, it's the 25. So you got plus 5 and minus 5. Don't forget your x's. And then 36. And so both of them will get a positive 36.